So integration with ln, here's our property that we're going to be using. You're going to really focus on this part, that when we integrate something, we want the du to be over the u, then it's going to equal this. So first step is let u equal the denominator, right? This is going to be kind of helpful. Yeah, because like, here's your property, so you want the u to be the bottom. Okay. Now, the reason why we can't do normal integration here is because, remember, we don't have a quotient rule with like integration. We don't have like a reverse quotient rule, right? So I don't really know how to do this otherwise. The only other thing to do is bring the x up and make it a negative exponent, right? But we'll get to somewhere we can't do that. Like, it's not possible. So we'll start with like basic ones first. Okay. Just keep in mind here for the big thing, we want du to be the top. Be the top. So we may need to take out constants. Or make a correction. Sorry, or make a correction. And then my last little thing was, remember, what do you guys need because we're integrating? Let's see. So when you guys first did integration, you know when we first learned about u substitution, where sometimes you had to find like the du part somewhere in the problem, and if you didn't have that, you had to make a correction and do more simplifying. This is kind of the same deal. So what we're going to do is let u equal the bottom. Okay. Now when we try to do du, what would the derivative be there? 1, good, yeah. So what we want is we want to find a 1 dx somewhere in here. But we may need to take out some constants. Did you guys see a constant from our original? 10. Good, nice, but yeah, good job. So we're going to take 10 out because it's a constant. So I'm going to move that. So what we end up getting is 10 and then 1 over x dx. So if you guys look at this part, we want to match it up using the property. We want to find du over u. This guy really calls me one more time today.
Hey, sorry, Sean. Sorry for being a dumb monkey.
No. Hey guys, this is the friend.
It was just a question.
Okay, so what we want is to find this property, right? Du over u. So in here, we want to see, do I have the du over the u now? So check it out. Here's your du, here's your u. See how it matches up? Okay, so this is good. Now when this happens, what we can do is say, well, when we integrate this, it's just going to be ln of the absolute value of the u plus c. So we're going to take the ln of the absolute value of your u, which is x plus c, but make sure you bring down your constant. So it's you need that. Oh, you don't need anything else? Yeah, you should. Yeah, you want the absolute value in there. Nope, that's it. Like I said, they do get way tougher, but
I don't like this.
we just need. I know this. I don't really like this.
Oh, so we don't have to do it?
No. No, sorry. We also do things we don't like to sometimes. Alright, so here's your next one. 1 over minus 5. This would be an example of like why we need to use this property, because you don't have a quotient rule for this. Yeah, we bring the whole thing up. We might be able to use u substitution, bring it all the way down to 1. Hi. Hiya.
Hey, ugly.
Alright, what do you guys want to let you be? Okay, good, okay, good. And then du is going to be just 1 dx. Awesome. Okay, so let's check it out. Do I have any constants to move or anything? No. This one's nice. It's already set up for you. You already had du over the u. So in that case, when we do this, all we have to do is take the ln of the absolute value of the u plus c. And that's it. Okay, where's the hard one? This isn't bad. What we're gonna do today is this stuff. Tomorrow. You ready?
Tomorrow, kill myself? Okay. Heard.
Okay. So keep it on. And we have no constants here to bring out. This is on the top. Okay, so we're going to let u equal the denominator, 4 minus 3x. Okay. What's the du going to be? Negative 3 dx. So we've done this kind of stuff before. There's no negative 3 up here. So what we need to do is make our correction. We want it just to be a 1 dx. Do you guys remember how you did that? Good. By negative 3. Awesome. Okay. So this is your correction. So what we're going to have is a negative 1/3, right? That's going to be our correction like out in the front here. So now when you guys do this, anybody have an idea of what's going to be left? Actually, I don't really need this. Probably some of this Good job. Plus. That's it. Right. So once you make that correction, then you have the 1 dx, so it's already like du over u.
Why wouldn't we just put it all over 3?
You could, Kyle. You're going to do like negative of that whole thing. That's fine. I just see it written like this more, but it's not wrong. Okay, exactly. So example 4. This
What?
okay, so here's another one.
Oh, yay! Correction of negative 1/3.
This is way too easy for you guys, isn't it? Your board.
No, it's fine.
There's no like
perfect difficulty. It's a good day.
Oh, I'm so tired, dog.
Kyle, what do you want you to be?
5 minus x cubed.
Great. Who's got the du? Ooh, good job for it. Perfect. All right, so we have the x squared. All right, we got the x squared, which is good, but we don't have that negative 3, so we need to make a correction, right, of negative 3. So it's going to be negative 1/3 out in front. Now, what you have left is what you want. You have your du already there. Anybody think they know it? Negative 1/3, I like that. Good. Perfect. Good job. Very nice. Right. Alright, let me give you guys a tougher one because these are too easy for you.
You don't have
This is good. Oh, 5. Sorry, I'm going off what I have here.
Is this our last example?
Probably.
Because I'm just going to
Yeah. Oh, I know what I did this year. Okay. Alright. So now, I just want to make sure like you guys kind of see the difference of certain things when you go through this. Okay, so I would rewrite. Like that's what you guys saw. X over we got 9 minus x squared is the 1/2. Okay. Alright. So in here, if you guys try to do this like kind of method that we've been using, what would you want to let u equal? Okay. Alright. What about the du? Good. Okay. So, with this part, now, what would, do you guys have the negative 2x?
Yeah.
Okay,
Oh, no.
good. We'll divide by negative 2. Okay, so we have a correction of negative 1/2. Now, did we address anything with this? No, okay. So you guys are gonna have to kind of like really, this is where it gets a little bit difficult because you have to start like thinking of when you have to use certain ideas.
Like
Wow.
it says the absolute value of u, so we do what we did with the last one we did, we put the 1/2 next to the u, like.
Yes, good job, Olivia. Okay, do you guys remember when you did use substitution? Okay, once you did this correction, we had a negative 1/2, right? And then this one would just be 1 over u to the 1/2. And then we changed it all into u's. Oh, I know. Right. So when you guys look at this problem, do we need to use our little ln stuff? Can we do regular use sub here? Yeah. How could you bring this to the top? Make it negative. Good. So we have negative 1/2.
I wouldn't know how to do this at all.
You know, this is getting into like.
Smart.
So we don't have to do ln. We don't need to here. It's actually way better not to. Because usually when you guys have these like extra exponents like this, it's going to be easier to do just a regular like use sub and some way like moving things. Now, how did you guys integrate? This is like going way lots of good. You got add 1. So if you guys add 1, what would you get?
No,
1/2. Alright. And then we have to multiply by 2 over 1, right? Or just 2. Now you have the negative 1/2 out here. Good, so it's like good. Negative u to the 1/2. What's your last step?
Ooh, sub the u.
Good, Aaron. Sub that u back in. Okay. So negative 9 minus x squared to the 1/2 plus d. Or, depending, I don't know how they're going to leave things. I mean, you guys also have this. If you did, now when you do your,
sounds more difficult, but
if you
You almost
did
said
that,
difficult.
and then you would use chain rule like.
right, to do your
Would it
du.
eventually work out?
Let's see, so 1/2, 9 minus, you would assume so, and then if you did chain rule, minus 1 times negative 2x. So we got negative x. No, I'm kind of curious. Actually, let me just stop this and then I'll work on this. Right. So here's your homework for tonight, guys. On page 340, 1 to 13 odd.
Please excuse interruption. There will be a unified sports basketball meeting today after school at 2:50 and 3:02 for all players.